Hey guys, Winston at Carbide 3D here. Contour operations are hands down the fastest way to get through material. But when you're trying to cut through thicker pieces of stock, particularly in metals, these toolpaths can bring a bit of extra drama to the equation. Without the absolute rigidity found on industrial-grade machines, any extra friction from touching both walls, bad chip evacuation, and/or suboptimal feeds and speeds can kick off some pretty nasty chatter and bog down the spindle. So how can we get around that problem? By using toolpaths that provide end mill and chip clearance. Reducing wall contact and providing ample room for chips to get out of the way will ensure that your spindle keeps humming along and your cutter can clear its flutes. The easiest way to do that is to enable a roughing pass with your 2D contour operation in Fusion 360. That runs the toolpath in 2 or more passes per step down, and it means that the end mill will only really be rubbing one wall at any given time. And if you play your cards right, that second pass on any given step down will be a very gentle cut, so it should produce really clean and accurate results. The only downside is that your cut takes twice as long, but there was some time penalty to be expected here since you're removing more than the bare minimum of material. Another option, which is my preferred strategy if time isn't a factor, is to use an adaptive toolpath. This way you get the benefit of tightly controlled cutter engagement, plus it distributes the cutting action over a larger portion of your flutes for better tool life. Normally, adaptive toolpaths are used for clearing out pockets or large open regions of material, but they can be harnessed to slot through material along a contour. Here's how you can do that. In the design workspace of Fusion, start by creating an offset profile from your part. This should be about 2 times the diameter of your end mill. Then, in your CAM workspace, create an adaptive toolpath that's constrained between your part and the offset profile you just made. You can use the same feeds and speeds you'd otherwise use with an adaptive toolpath in any given material, but because the cutter engagement period is so low, sometimes I'll crank up the optimal load just a little bit so that the machine cuts faster. Be sure the diameter of your ramp-in helix is smaller than the diameter of your cutter so that the end mill will be able to spiral in within the boundaries of your profiles. And of course, keep a few thou of radial stock to leave so you can clean up the walls with a finishing pass later. The downside here is that depending on your optimal load, the time penalty can be more than double that of a plain old contour cut. The shallower each arc is, the more time is spent looping back around to set up for the next cut, even with both ways enabled. And with larger projects, the calculation time can become quite prohibitive. If you want to get a little more advanced, you can save quite a bit of time by using stock that's sized appropriately to your model and some intelligent model placement so that Fusion can take advantage of opportunities to increase efficiency. If it sees that there's no stock on one or more sides of your part, it'll skip the small arc movements and feed in a more linear fashion. To do this, you'll need to create your cam setup in a way that accurately reflects how your stock and origin will be set up in real life. Then enable stock contours in the geometry tab of your toolpath. Now, Fusion will know it can feed more linearly when the end mill is not fully surrounded by stock. So these are 2 strategies that you can employ to take some of the anxiety out of deep slotting or contour toolpaths, especially in conjunction with strategic vacuum or air blast application for chip clearing. Again, you probably won't need these in wood or plastic, but if you're machining more than about 2 end mill diameters deep in metal, it might be worth opting for a slower but steady and stress-free toolpath to cut out your part. I hope these tips help you in whatever you're making. Good luck and have fun machining, folks.